Good morning, everyone. My name is Karthik Ramakrishnan, and I am the sales engineering lead at Corelight for Middle East, Turkey, and Africa region. It gives me great pleasure to be here today to talk about Corelight's Open NDR platform that organizations can leverage to make their security operations teams more efficient and attain a stronger cybersecurity posture. I will take you through a technical overview and a demo during this session. But before we get into it, I wanted to touch upon some of the challenges our customers are often facing in terms of detecting threats, such as C2 communication or lateral movement, or threats hiding within encrypted traffic. Incident response scenarios can often seem like solving a jigsaw puzzle, and the biggest challenge is to ensure that we have all the pieces of the puzzle. Meaning, do we have the right data? Data that can provide definitive answers to questions like, do we know the root cause of this incident? What systems were affected? Can we be 100% sure that no data has been exfiltrated? And hoping that the attacker has not tampered or deleted the log data to cover up their tracks. Being able to hunt for threats proactively allows security teams to detect and respond to advanced threats faster. But it begs the question, do organizations have the right data and tools? There are only really three places you get data from when you're talking about IT security: the network, the endpoint, and threat intelligence feeds, all feeding into a SIM or an XDR solution as centerpiece in the context of a modern SOC. EDR data can provide rich telemetry into processes that were executed, artifacts generated on system, details about installed software versions, and so on. Organizations also need to have network-based visibility in the form of NDR. There is a wealth of information in the network. For example, every email, DNS request and response, websites visited, files downloaded, C2 activity, malware lateral movement, data exfiltration, and so on and so forth. All of this has to traverse the wire. Whilst each of them have their benefits and drawbacks, for example, it's a common attacker technique to tamper with endpoint security software. So even if you've maintained thousands of agents properly, you might still miss something critical. Some systems like IoT devices, you can't install an agent even if you wanted to. Network data, on the other hand, may not be able to tell you exactly what happened on a specific host, but because every host has to touch the network and every attacker must go through the network, monitoring these resources ensures that you don't miss anything. Network data is a critical source of truth for incident responders and threat hunters. Also, since unlike some of the other log sources, attackers cannot tamper with packets across the network, making it much harder for them to cover their tracks. Combining these two sources of data, along with third-party threat intelligence and indicators that assist with detections, is the only way to get a truly complete picture of the security of your enterprise. Well, if it's as simple as network, endpoint, and threat intelligence, why does it turn out to be so complicated in the real world? Because most organizations collect the data they need in this manner. No doubt many of your systems, such as email, web, DNS, file servers, and so on, are being monitored. And some would argue that some monitoring is better than no monitoring. Well, unfortunately, not adequate to detect and respond to advanced threats. Network data in particular comes from a variety of different sources, such as application servers, different security devices, network tools, and in a variety of different formats and levels of detail that were never designed to create a common schema about the network from a security perspective. There's a huge gap when it comes to the richness of the data from disparate sources, leading to a serious problem translating the data into a usable form. Also, because these sources were never made to provide security visibility. For example, DNS logs from Active Directory servers don't contain the response to the DNS queries devices were making. So it's impossible to figure out what happened after a suspicious resolution was made if that is your only source of DNS data. An interesting report from FireEye called as the M-Trends report talks about the global dwell time. So dwell time represents the length of time a cyber attacker has free reign in an environment from the time they get in until they are eradicated. According to this report, in 2020, the global median dwell time dropped below 1 month for the first time. This decline could be explained by several factors, including continued improvement in threat detection capabilities, new policies, and higher security budgets. However, the attack landscape plays a critical role. As dwell time dropped last year, the number of ransomware cases rose. Ransomware attacks, which by nature have a shorter dwell time, are growing more common and efficient, shrinking the average time frame for all attacks. Keeping ransomware aside, another notable fact is that the incidents with external notification sources came in at 73 days. It is still quite common for organizations to be notified by external sources such as law enforcement agencies, national certs, and third-party threat researchers, especially organizations who are still not at a certain level of cybersecurity maturity. And that, to be honest, is most organizations. It often takes too long to detect attackers. And while they're roaming your network undetected, they can be doing some real damage. The report showed the average dwell time for an attack was a little over 3 months. Sorry, almost 3 months. From the point of initial access to exfiltration, going through the various phases as defined by MITRE's attack framework, to the point where a threat is finally discovered, especially if you're relying on logs from the disparate data sources that I mentioned earlier, you are getting little to no visibility into such an activity. So how can Corelight help reduce the dwell time? Corelight's Open India platform can get you the information you need. Corelight sensors are collecting relevant security data 24/7. What you see here in this example attack are specific TTPs, also called as tactics, techniques, and procedures, that an attacker may take over the course of their exfiltration. Along the way, if you had Corelight sensors deployed, they would be extracting and collecting data from your network traffic. At each step in the kill chain, relevant data is collected about the TCP connection, the DNS requests and responses, web pages visited, files downloaded, authentication, and so on. Now let's take a look at Corelight's Open NDR platform in terms of its functionality. We call it Open NDR because of our open source heritage. Zeek, formerly known as Bro, was created in 1995 and has been considered to be the gold standard in network security monitoring for over 25 years. Zeek has been widely adopted across civilian, military, and intelligence agencies, foreign governments, universities, and so on. Over the last 5 or 10 years, more enterprises have adopted Zeek because there is no better way to extract data for security from network traffic. The creators of Zeek are also the founders of Corelight, which is the commercial arm. We maintain the open source offering as well, and it is powered by a community that has thousands of contributors. So not only can you benefit from the research and development that we do at Corelight, but also from custom scripts and packages from the open source community. In terms of the key elements of Corelight are the behavioral detection packages that are all pre-built with the enterprise version. Behavioral detections and insights have been the core of Corelight's offering from the very beginning. These come from open source community, from Corelight, and from when you build your custom packages to add to the platform. Packages built by the community are open to all, whereas the packages developed by Corelight Research are exclusive to Corelight customers. For example, the encrypted traffic collection and the C2 collection that I will talk about in more detail in just a little while. Another key component that also sets us apart from our competitors is the signature-based detection engine, built into the Corelight sensor. Suricata IDS engine, yet another extremely popular open source technology. The rules database comprises of 65,000 rules in over 50 different categories and is updated daily by threat intelligence feeds to provide alerts into malware, phishing, C2, remote access Trojan, among others. The combination of Suricata and Zeek in a single platform is unique because it gives you the ability to drill down into an IDS alert using Zeek metadata so you can quickly investigate further. In addition, the ability to selectively capture PCAPs triggered based on various factors allows organizations in heavily regulated industries such as banking and finance to be compliant as well. Now, with the detection and the alerts, there are 70 different log types that are created. These log types are structured and linked sets of relevant data that are extremely useful in security investigations. So in this example, we talk about the 5 of the most popular Zeek logs that are used for any analysis or investigation. And you can see a couple of things here. So let's start in the middle with the con log or the connection log. It's probably the most central of all Zeek logs because every TCP connection generates con log data. In fact, each connection is given a unique ID, highlighted in blue here. As you can see, other logs also include the UID. So analysts can pivot quickly from con to other logs to examine DNS requests and responses, web pages visited, files sent, emails, and more. I mentioned our encrypted traffic collection. So these are a set of insights drawn from both Zeek community and our research team to provide insights into encrypted traffic without having to decrypt it. Now, any security operations analyst would tell you they'd much prefer to have unencrypted traffic, and we agree. But while there are many products that do man-in-the-middle decryption or that terminate connections, it's not always possible to implement those solutions for several reasons. Some of the key insights provided using the encrypted traffic collection are SSL fingerprinting. So this creates a hash of every SSL, TLS, client and server negotiation for use in threat hunting or intel feed matching. SSL certificate monitoring. So this can track expired and soon to expire certificates, newly issued certificates, self-signed, invalid, change validation errors, weak ciphers, weak key links, bad versions, and so on and so forth. The SSH client brute force detection reveals when a client makes excessive authentication attempts. The SSH authentication bypass detection reveals when a client and server switch to a non-SSH protocol. And DNS over HTTPS detection, for example, reveals when DNS queries are made to known DNS over HTTPS servers to provide insight into DNS traffic that would otherwise be hidden. There are specific log types generated for encrypted traffic that allow you to dig deeper into any of the insights that I just talked about. Another package called as the C2 detection or the C2 collection is actually a collection of packages for Corelight customers only, and it is available as a part of an existing Corelight subscription. This is focused around the MITRE attack command control category of TTPs, designed as data enhancements, inferences, and detections. The HTTP C2 flags select command control patterns in HTTP traffic on your network. And when it identifies C2 patterns, it raises a notice to flag the traffic and identifies which C2 infrastructure is recognized. The DGA detection package, for instance, identifies potentially malicious traffic on your network by flagging DNS activity that's likely associated with a known domain generation algorithm. Now, let's talk a little bit about the architecture and typical deployment scenarios of the Corelight sensor. We start with the Corelight sensors, which are essentially available in 4 different variants. The physical sensor, which is a pre-built appliance, provides the highest levels of throughput ranging from 2 gig to 100 gig in a 1U form factor. We are proven in very high throughput environments for scalability and extensibility using a physical sensor. The virtual sensor, which can be run on VMware and Hyper-V. We have the cloud sensors that are public cloud certified elements. So if you're using AWS, Azure, or GCP, we can provide you a sensor for deployment. The software sensor is designed for microservices, containers, small form factor computers, suitable for small branch offices. So the Corelight sensor is a passive device that receives a copy of the network traffic from a span port or a tap device or a packet broker. The Corelight sensor then extracts metadata from the raw packets, applies behavioral-based packages and threat intelligence feeds. Using threat intelligence feeds from providers such as ET-Pro, MISP, and our newly announced partnership with CrowdStrike, Corelight customers will be able to incorporate best-in-class threat intelligence into Corelight sensors to generate actionable alerts and network evidence. Coming out of the Corelight sensor is the high-fidelity, rich metadata extracted from the traffic in addition to the alerts, which can then be exported to any of the next-generation visualization platforms or security data lakes shown here. You can even choose specific log types and export to multiple visualization platforms. For instance, you can export select log types to your SIM for day-to-day incident response and export all logs to a data lake for long-term storage. You can optionally enable file extraction, so files can be sent to malware analysis solutions for further analysis or stored for forensic purposes. So as you can see, a very simple and straightforward architecture that can be deployed very quickly. Drilling down into the solutions options, as I mentioned, there are 4 deployment options: hardware, cloud, virtual machine, or software. The hardware appliances are available in 3 sizes, 2, 10, 25, and 4 sizes, 2, 10, 25, and 100 Gbps. The VM options support VMware and Hyper-V, and Cloud Sensor can be deployed on AWS, Azure, or GCP, as I mentioned earlier. And our software sensor are extremely flexible, deployable on virtually any 64-bit Linux server. We also offer our Fleet Manager, which enables the management of up to 250 Corelight sensors from one place. At the highest level, our solutions help you in 3 key areas. We provide blue teams, incident responders, and threat hunters with the evidence and context they need to gain insight into attacks, whether in real time or in the past. Our solutions are built primarily on open source technology and are driven by data that can be incorporated into any analytics stack or framework. You own your data and you're not dependent on any particular product or company. Having the right data and evidence at hand can make a dramatic impact on how long it takes to resolve incidents. That brings me to the end of the technical overview, and while I transition to the demo, I will let you read through and ponder over this quote for a moment. So what I'm going to do now is to show you how easy it is to get the rich metadata that Corelight generates into the various visualization platforms that I talked about. The setup that I'm going to use comprises of a packet broker that is feeding the Corelight sensors, and we are exporting the logs to Splunk. So I will show you in the Splunk user interface how the logs look and how easy it is to you know, search through them or go through an incident response use case or a threat hunting kind of activity. So we have the homepage of the Corelight sensor right here. And it shows us some basic information related to the active ports that are ingesting the traffic, like I said, from a span port or tap or a packet broker. And here we can see that all the services are healthy and the exporters that have been set up to send the logs, like I mentioned, Splunk in this case. So we are Splunk Common Information Model compliant, and we do all our user normalization ourselves. We also maintain our key value pairs before exporting this data into Splunk. Exporting data into Splunk or any other visualization platform for that matter is fairly straightforward. So all you need to do is, so in this case, like I said, we're using Splunk. So all you need to do is provide the IP address or the host name of the Splunk deployment server. And that's it. You're pretty much good to go. If you want, you can send it to the main index, or you can change the index to something like Corelight, in which case you would have to append index equals Corelight when you're doing your search queries in Splunk. And this is a built-in universal forwarder, and all you have to do is enable it, like I said earlier. We also have built-in packages that I was talking about earlier. Now, so some of the core packages that we have, for example, to detect cryptocurrency mining traffic related to Bitcoin and other cryptocurrencies, the Eternal Safety package is to detect the Eternal family of Windows exploits on Microsoft SMB protocol. The exploit was originally developed by NSA, but was leaked and subsequently used in ransomware attacks such as WannaCry and NotPetya. There are packages for detecting JA3 and JA3S hashes. There is a package that detects based on MITRE Bazaar as well. And the encrypted traffic packages that I touched upon earlier has components such as certificate hygiene, where you can see being able to do certificate validation, being able to check for weak keys, expiring certificates, and so on and so forth. We can look at DNS over HTTPS, RDP inferences. I talked about a little bit about the SSH inferences package as well that we have. And I'll take you through some of these when I transition over to the Splunk user interface so you can understand that better. So once we're done configuring the Corelight sensor, and literally, like I just showed you, it just takes minutes to do that. All you need to do is provide the traffic ingest and define where you want to export the logs to and enable the packages that you want. So now that this is all done, you can directly move into Splunk UI or any other visualization platform that you're using. So specific to Splunk, what we've done is we've created an app for Splunk that you can download from Splunk base or directly from your Splunk instance if it has internet access. Now there are 6 major tabs within the app, and there are a few different ways you can interact with Splunk when it comes to Corelight data. First is the detections based on Suricata IDS signatures, as you can see right here. And then there are detections based on threat intelligence feeds that we ingest within the Corelight sensor to enrich the data. We also have indicators and dashboards for detections based on algorithms we run within the packages. For instance, you can see here that there are detections based on the packages that I just spoke about. So, for example, Bitcoin miner. These are all detections related to the MITRE Bazaar package that I was talking about. And then there's a detection, there are detections related to the eternal safety package that I spoke about. And last but not the least, you can also take a look at the various logs that we generate, such as DNS, HTTP, conlog, and so on and so forth. So I'm going to take you through some of the logs that are most popularly, commonly used, and are the most important for typical incident response and threat hunting scenarios. So the connections, or the con log as we call it, is interesting as it is quite rare to get network data in a SIM in this fashion. So for instance, we show details around how much data is coming in, where is this data coming in from, and where data is going to, and what protocols are being used as well. So if you see a service or a protocol that shouldn't be there, you can easily respond to that. You can also take a look at all the top originators, top destinations, the amount of data that is being sent, in addition to the duration of connection. In terms of DNS, so DNS health and visibility are key to detecting attacks based on DNS tunneling and domain generation algorithms, wherein adversaries may communicate with the DNS application layer protocol to avoid detection by network filtering, by blending in with existing traffic. So commands to remote systems, and often the results of those commands, will be embedded within the protocol traffic between the client and the servers. And a classic example of this was seen in the recent SolarWinds Sunburst attack. Now, with Corelight platform, we make it very difficult for adversaries to use these techniques to hide under the hood. One way to detect this is by looking at the widget on the right that shows queries to non-existent domains. This begs the question that if a domain does not exist, how and why the user initiated a DNS request? Or was it even user initiated to begin with? In most cases, this is a typical malicious behavior wherein an infected host phones home by trying to contact pseudo-random domain names for downloading more malware or to gather further instructions. Another clear-cut indicator of bad behavior is the number of DNS queries. So as seen in the bottom left, the widget that keeps track of the count of DNS queries, unless it is a DNS server, it is highly unlikely for a host to generate these many DNS requests. So let's say a user during the normal 8-hour workday generates 400 to 500 DNS requests, and suddenly they start generating much more, like 4 or 5 times, or even more than that. You could use that as a trigger to create an alert within Splunk to proactively monitor such instances. In addition, not only do we have a record of the DNS requests, but we also maintain the response. So as I had mentioned earlier, if you are collecting logs from a DNS server, you don't get visibility of the DNS responses. And it's very critical in an incident response scenario to have this piece of information. So for example, if somebody is going to a specific website, uh, you should be able to validate that it is that website that is answering back, and not a rogue website, or not a malicious sort of a man in the middle that is responding to those queries. In terms of the HTTP logs, as I mentioned earlier, Corelight generates over 70 different log types, but we are going through some of the most common ones for easier understanding. Within HTTP logs, we can look at both forward and reverse proxy traffic that uses while going to the internet, and the internet talking back to your web service and so on. Here we maintain status codes that we see along with rare host headers and rare user agents within the traffic. Any anomalies seen here can be very powerful indicators to start digging deeper. We also give you an understanding of the software logs. So what kind of softwares are running within the infrastructure, so things like Apache, Linux, IIS, Firefox, and so on. So for example, if you see somebody using a very old version of a particular browser, you can easily pinpoint to that as well. File logs are very critical as well. And in the demo that I will do a little later, I will show you an example of why file logs are very critical. We look into files, and we have the ability to extract files from the wire. We maintain a list of all the files that traverse the network, whether they are text or Java or Flash or even archives. We also keep a track of the protocols that are being used to download or access these files. So, for example, you can also take a look at executables hidden by file names. So they are masquerading as an image file. And because we detect the true file type or the MIME type, we're able to give you that visibility. Now, moving on to encrypted traffic collection, I briefly talked about the log types that are generated by the encrypted traffic collection packages. So you can take a look at things like top certificate subjects, or you can flip that around and say, show me rare subjects. So if these are rare subjects being used, then that's where you may find anomalies and potentially something malicious. You could also have a dashboard for any self-signed certificates that was used, and any certificate with a failed validation status. So the beauty of using Splunk and similar visualization platforms is that apart from the dashboards that you get out of the box, the sky is the limit in terms of customization, in terms of creating your own dashboards that give you more meaningful data. So continuing with the encrypted traffic collection, you can look at, instead of looking at each certificate and their ciphers, you can just look at client-server negotiations that Corelight will pick up and can easily point out and say, you know what, this one is using triple des. Maybe this is something you don't want to use. And we want to upgrade so it becomes easy to manage SSL as well. One of the other key aspects of the encrypted traffic, as I had mentioned earlier, is the SSH inference overview. All the data you see here has been detected and classified by our packages without doing any form of decryption. So something like an automated password authentication, client authentication bypass exploit, scanning authentication services or a port scanning to see if SSH is running on port 22 or 2022. We can also look at keystrokes here. So that gives you a lot of visibility around what is happening within your traffic. When it comes to SSH, we maintain host keys, destinations, and within the inferences themselves, we can show you everything that we've observed. And this is really important when you have a visibility issue with SSH. So I talked a little bit about Suricata, the alerts that we generate from our signature-based IDS engine, and I also mentioned that you are able to create custom dashboards. So this is one example of a dashboard that has been created. It's not available by default. So as you can see, you can get some geolocation information, things about top infected hosts, top Suricata alert signatures, and so on and so forth. So like I said, you can create custom reports and dashboards to your liking. Okay, so now that I've provided you a little bit of an overview of the features, the functionality, how the logs, how the metadata is extracted, how the logs are exported, and so on, I want to take you through a quick exercise so that you get a better understanding of what I've been talking about all this while. So what I'm going to do is I'm going to start off by using the notice logs, which is essentially showing you all the alerts coming from the behavioral detection side of things that we have. and also the threat intel side of things. So what we notice here is an alert that says invalid server certificate, and we will dig deeper into this a little bit more. So due to a sense of time, I've opened some of these windows prior to give you a more seamless demo experience. So I click the alert and I'm able to pivot into the underlying events. And so this underlying event basically tells me the source IP, the destination IP, and it says SSL certificate validation failed, and it was using a self-signed certificate. Okay, so not saying self-signed certificates are bad all the time, but because this was an alert, I want to dig deeper and figure out what's going on. And this has been triggered by Corelight certificate hygiene package, part of the encrypted traffic collection that I mentioned about earlier. And so this gives some clues that there's some suspicious, a suspicious TLS connection was established, so to speak. Now, I'm going to take a look at other SSL connections from this particular host. And when I do that, I notice that this host has been very chatty. It is talking to a number of external hosts using the self-signed certificate. So it's a TLS connection. But what's noteworthy is that it is also using non-standard SSL ports. And the other thing that's quite interesting here is I talked about JA3 and JA3S hashes earlier. So despite the changing IP addresses and the ports, we are able to detect the JA3 hashes, and we can see that they are same for all of these SSL connections, and that indicates a highly suspicious flag. So what I'm going to do is I'm going to check this JA3 and JA3S hash pair. Just do a web search for it. Now, JA3 hashes were created by Salesforce. Salesforce, for those of you who don't know. So I do a check, and this hash corresponds to a well-known TrickBot malware. And the way it communicates using the client hello with its associated CNC server, and the way the server responds back with the server hello message, it is, it's a known sort of a malicious communication. So now that we've established that it is something malicious, I want to try and dig deeper into some of the other logs and get more insight. So obviously, this is a communication that is happening on the internet. So I'm going to take a look at DNS logs to see if there are any DNS logs pertaining to this. So now that I know that this is the IP, I've run a query wherein I'm looking for this as the source IP address, and I can see that there is quite a bit of DNS activity going on here. I also want to take a look at the HTTP logs to see if there was a web browsing activity, if there is any malicious files being downloaded, and so on and so forth. And when I start taking a look at the HTTP logs, I see that there are some instances of application /x.exec, which essentially means that it's a executable file. And that sort of piques my interest, and I really want to get sort of into it and find out what's going on. So now what I can do is I can take a look at the files log, which would then give me the cryptographic hash information, MD5 specifically in this instance, for the executable files that we saw were downloaded. I can now take one of these MD5 hashes and determine whether they are malicious or not. So I search it in VirusTotal, and I I'm told that it is definitely malicious. So we've got malicious activity going on, definitely. Now, I talked a little bit about one of our key features, which is the UID or the unique identifier um, that we use to tie in different logs. Now, I picked one of these unique identifiers, UIDs, and I did a search for it to see, and I basically get all these different logs. So there is the connection log, there is the files log, there's the HTTP log, and there is a Suricata um, log as well. So this unique ID is basically able to tie all these different logs together. And if I wish, I can pivot into each of these logs and take a look at uh, the individual activity of that particular session for each of these protocols. And that's really one of the key features and the power of the Corelight sensor. So now that we've established that something malicious was downloaded, now I want to sort of go further and figure out if there was any lateral movement of this malware, right? Because that's what happens in a number of instances when, especially when advanced threats um, attack their targets. The first point of infection is usually the weakest point, and it does not probably store anything useful that the attackers want. So once they get in there, they want to try and move laterally. And what we did was we did a quick MD5 hash search, and we noticed that, so this is our original IP, 10.430.101. We noticed that the hash was found on another IP address, two instances. One of the instances, this IP has actually reached out to an external host, a public IP, and downloaded it. And in the other instance, it has been transferred from the originally infected host. I can also validate that by taking a look. So I see here, based on the MITRE Bazaar package that we have, that this is being termed as a lateral movement attack. It says SMB file write to admin file share, and here you see the source IP, the destination IP, and how it is accessing the Windows $C share to transfer the malicious executable file. So what we've essentially done here is we've looked at the full infection life cycle, starting from the first host machine that spreads to another host on the internal network. And a few key things that I want to sort of reiterate here. So if you remember, I spoke about the ability to do threat hunting and the necessity to have the right data and tools, and the ability to answer all the questions, so to be able to put together the pieces of the jigsaw puzzle. So the analyst here was able to connect the dots successfully for the Strigbot infection using the Zeek logs. And the best part was there was no need to pivot on the endpoint in the first place. So we did everything only from a network perspective. And so this is why I left you to ponder over that quote while I was setting up my demo. And this is why I kind of agree with that quote. So you have the network that is kind of creating an outline for you, and then you can use the host to fill up the complete the puzzle inside. So going back to being able to answer the questions definitively. So we were able to answer all the questions here definitively. So what was the source IP of the initial infection? Right, we know that. Did the infected machine connect to malicious domains using SSL? Yes, it did. We saw that it connected to some malicious domains. Did the infection spread laterally to any other machine? Yes, it did. We just noted that as well. So it's really important to be to have the right data and the right tools, as I keep saying. And so, in terms of next actions, if you're an analyst, calls for remediation actions, contain the infected endpoints to prevent further lateral spread, trigger workflows to block access to malicious domains and IP addresses at firewall, proxy, IPS, as observed from Zeek logs, perform forensic investigation on the endpoint to clean malware infection. And obviously, you've got to validate and be sure that this is over, that there are no more systems in your environment that are trying to connect to this or any other command control servers, post the malware cleanup. So to wrap up, I just want to kind of reiterate what I've mostly been saying throughout the session, is that the key to insight is to have the tools to see everything on your network without having to monitor every endpoint, application, and host. Of course, those technologies are critical as well, but the key is to capture, connect, and interpret the evidence that matters. And we at Corelight can help you get there very quickly with some really powerful solutions that we have. Thank you for listening. I hope the session was useful and informative. I'm happy to answer any questions if there are.